Welcome to qnawire.
Hello, today we'll be probably finishing up our probability distribution discussions with this final example. And our example today is that if we are looking at the probability of 1, 2, 3, or 4 video games being played in one night, we know the following. A, the probability that one game is played is half as likely as 2 games are played. The probability that 3 games are played is twice as likely as that 2 games are played. The probability that 4 games being played is equivalent to the average of the other 3 probabilities. And lastly, we will be constructing the probability distribution for this random variable and drawing its accompanying graph. So let's start out with the fact that that's a lot of information. So let's start out with breaking it down. So let's look at A first. So the probability that one game is played. So there we go. The probability that one game is being played, or one game is played, we'll denote as probability of 1. We've seen in the past that we put probability of x and x for writing out our probability distributions. So we can put in that the probability of 1 being our value of x is 1 in order to denote what's happening with the information that we're being provided with. So the probability that one game is being played is 1/2 as likely as 2 games are being played. So probability of 1/2, probability of 2. Now for B, the probability that 3 games are played is twice as likely as 2 games are played. So probability of 3 equals 2, that's the probability of 2 games being played. And then lastly, the probability of 4 games being played is the average of the other 3. So probability of 1 plus probability of 2 plus probability of 3 over 3. Go. And now one rule that was not listed in the problem, but we know because we're working with probability distributions, is that the sum of all of our probabilities must equal 1. So with these 4 equations, we can figure out what all of our probabilities are. We'll start this out by trying to find all of our ratios of our different probabilities. So we'll start this out with the probability of 4. And we're going to first look at all of our probabilities and turn them into ratios in relation to probability of 1. And we'll be doing this by looking at it. So probability of 1 equals 1/2 probability of 2. But we prefer to look at these in whole numbers. So we're going to change that over to that the probability of 2 equals 2 times the probability of 1. Probability of 3 then becomes 4 times the probability of 1. And from there, we can look at the probability of 4 and use it specifically in terms of probability of 1 to determine what the ratio between probability of 4 and probability of 1 are for this problem. So we'll do probability of 4 equals probability of 1 plus 2 times probability of 1 plus 4 times probability of 1 all over 3. Probability of 4 equals 7 times probability of 1 over 3. Missed that parentheses. So now we can see that our probability of 4, 3 times our probability of 4 equals 7 times our probability of 1. Now, from this determination, we can look at our relations between all our probabilities, and we can do probability of 1 equals probability of 1. And from this, we can determine that the least amount of games that we can use to determine these probabilities has to be the least common multiple of all of these values, and that will be 7 and 4 for us today. So our probabilities have to be out of the value 28. So from that, let's go ahead and start drawing our probability distribution, and that part will make more sense once we have it drawn out in a slightly different way than what we have been doing in the past. So our x values can be 1, 2, 3, and 4. Here we'll do our number of games calculation, and then our p of x value. Our probability of each x will be over there. So we'll start with the number of games for our 1 value. It'll be 1 times 3. Our 2 value will be 3 times 2. And we'll have 3 times 4, 3 times 7 over 3. And as you can see, all of those values are based on our ratios we calculated before. So then we get that we will have 6, 3, 12, and 7 videos for each section. So our probability of 1 game being played in a night are 3 over 28. And we have 6 over 28 for 2 games, 12 over 28 for 3 games, and 7 over 28 for 4 games. And then again, we can simplify all of those down to 3 over 7, 1 over 4, 3 over 14, and again, 3 over 28. Okay. And now we're going to real quick graph all of that. So our graph, we'll go ahead and insert a grid. Make it a little bit smaller. Okay. And now our graphing of all of that, we will have our, as usual, we'll need our x values, which will be 1, 2, 3, and 4. Then our y values will be, this time we're just going to do from 0 at the base to 1, because putting in 28ths I think will get a little too complicated. And so this will just be 1/2. And we'll have 1/4 and 3/4. Okay, so for our x equals 1 value, we have 3 28ths, which will go up to just about here. Our second value is 6 over 28ths, which will go up to right about there, I believe. Next, we have 12 28ths, which is almost 1/2, right about there. And then our next 7 28ths is right at 1/4. And that is our graph for our probability distribution as well as the probability distribution table for this random variable.